you're probably wondering what the octet rule is. So an octagon has 8 sides, so an octet means 8 valence electrons, or rather 8 of something. So that's because, think about it, triplet is 3, quadruplet, quintuplet, and so on. Yeah, so octet. So 2 for hydrogen and helium. Why is it 2 for hydrogen and helium? Well, it's because the innermost electron energy level can only hold how many? It can hold up to 2n squared. If n equals 1, max is therefore 2. What about n equals 2? The max is 8, n equals 3, max is 18, and so on. Now, since we're talking about ions, well, what do you think happens when atoms combine, and if they are an ionic compound, what happens? Electrons transfer, because ions are charged atoms or molecules. So how are they charged? Because they have more or less electrons than they're supposed to. So, with the octet rule, we generally achieve 8 valence electrons. Covalent bonding, also sometimes called molecular bonding, uses sharing electrons instead of transferring like ionic does. Now, what is a noble gas? Well, these atoms have an octet already, or helium has 2, and they're especially unreactive. Now, this is a blimp, or an airship, depending on who you ask. Now, modern blimps are full of helium. They used to be sometimes filled with hydrogen instead. Hydrogen is slightly lighter than helium, but unlike helium, it is very flammable. So in 1937, the Hindenburg blew up. Well, it caught fire, but it might as well have blown up. And after that, the age of airship travel basically ended, or at least hydrogen airship travel, because people were scared. Now, of course, calling these noble gases, in some languages, the name is less glorious and tends toward lazy gases instead. Now, you might have seen these names on the periodic table, which looks like this. Now, helium, neon, and argon are the first 3 noble gases. So when you run a current through them, they show up in different colors, as you can see here. And of course, these are used in what we usually call neon lights. They are not, of course, always neon. Now, on the subject of ions, well, they're charged, and they happen when atoms or molecules gain or lose 1 or more electrons. Alright then. Now, a cation is positively charged. So, it must have lost electrons, because electrons are negative, right? Now, the valence, this might seem a little confusing, given that we talk about valence electrons being the outermost electrons on an atom, and the valence of an ion is the charge on the ion. Well, I guess they just really like this word for some reason. Now, an anion is negatively charged. How can you remember an and cat? Well, you can think of this as having a T, and when you write a T, it's what? It's a plus sign, right? And an, well, anoxic is when you don't have enough oxygen. Or anhydrous, when you don't have water. So an is one of the prefixes that we can use for no. And no is like a negative response, right? So, negative. Although that is probably more effort than it's worth, and brute forcing both of these might actually be more efficient. Well, it is more efficient. Now, here we have an ion. What ion is this? Oh, 11p? So 11p means it is sodium. Yeah, it's sodium. So this is written as Na plus. And how do we generate this? Well, plus E minus here. And energy. And since this is relatively small, we can draw the full of N. And while P plus and N0 are rarely asked for, E minus is somewhat more common. And of course, we know that we start and end with the same amount of electrons. In chemistry, we have conservation of mass. In physics, we sometimes do not. Now, what happens when an ion has more than one atom? Well, it's called a polyatomic ion. And this is what happens when you ionize a molecule. So say you start with a phosphate molecule, which is PO4. PO4 exists most commonly in the 3 minus form. So, what does it usually combine with? Well, if you've seen the labels on Coca-Cola, phosphoric acid is H3PO4. It's one of the things that makes Coke so bad for your teeth. Now, some polyatomic ions can look pretty scary, such as ferrous sulfate and stuff on food labels, but, well, many are required for good health. Now, there's a story here about phosphate-free detergents. So, a few decades back, and again now, the dumping of phosphate-based detergents into Lake Erie was so serious that basically the south half of Lake Erie, or well, the southwestern half of Lake Erie was one big dead area because the phosphate concentration in the water encouraged overgrowth of algae, and this decaying algae eventually, well, consumed the oxygen in the water. Why is this important? I mean, you might be thinking, hey, wait, aren't algae photosynthesizers? Well, think about this. So we have water, and we have algae, and yes, they photosynthesize, but the oxygen goes up here. So oxygen does not dissolve very readily in water. But when the algae die, they sink. Yeah. They sink, and then they decay. So when they decay, the bacteria that digest them prefer to do so aerobically, i.e. consume oxygen. Why? Because it provides them with more energy than doing this anaerobically. Now, when they die and decay, down here, you end up with less oxygen. So this deoxygenated water does not turn over very easily, and water has a low capacity for oxygen. Hence, the problem. What happens when you have too much deoxygenated water? Fish cannot survive, particularly bottom feeder fish. And there are many bottom feeder fish in Lake Erie. Why do you think that is? Well, the lake is relatively shallow, and so light can usually reach the bottom. And if light can reach the bottom, stuff might be able to grow at the bottom. Well, more stuff than, say, the abyssal zone of the ocean. So if there's stuff growing at the bottom, yes, that releases a little bit of oxygen, but it's not enough to compensate for this overgrowth and decay. So, if there's stuff growing at the bottom, there are naturally fish that eat that stuff, right? But now they can't live there anymore. So, bad things happen. Anyway, That's why now in Canada you see usually on detergent bottles phosphate free because of the Erie disaster. So we won't mention the time that Lake Erie actually caught fire, but that was a unrelated thing, not related to phosphate. In summary, the octet rule states that atoms are happiest, i.e. they prefer to reach a stable octet, i.e. 8 valence electrons. Why? Because this is a valence arrangement of the noble gases, which are, as we know, unreactive and therefore stable. So, ions are atoms or molecules that have gained or lost electrons. Now, what happens when ions have many atoms in them, i.e. they are themselves molecules to begin with? Well, they're polyatomic ions. Now, metals tend to lose electrons to form cations, whereas nonmetals tend to gain electrons to form anions. Why might this be? Well, if we look at a pretty picture, i.e. a periodic table, we find that for the nonmetals, it's faster to get to the nearest noble gas configuration by gaining electrons. Whereas for metals, it's faster to lose them. And since we talked about how these metals were filling up the intermediate layers, after getting these two on the outside, that is actually basically AP level stuff, by the way. That means that these also tend to lose, and then they have a full outer shell of at least 8. Now, multivalent elements can form 2 or more different ions. What examples can you think of? Well, we know there's ferric oxide, and there's ferrous oxide, and there's magnetite, and so on. Well, that means iron can be both +3 and +2. What about some others that you can think of? Well, copper has cuprous and cupric that they used to use before they decided to use copper 3 and copper 2 oxides. And what does that mean? That means copper can also form different valences. Now, many ions are of course necessary for good health. If you've ever seen calcium carbonate on a calcium pill bottle, well, that's CaCO3. Now, what is this in terms of ions? This is Ca2 plus, CO3 2 minus. And we all know that you need calcium to build bones, right? So, that's it for this section. I mean, yes, okay, some ions are not good for the environment, but, well, anything in excess is not good for the environment, right? Well, that's it.